Okay, so now we are ready to talk about solution concentrations and reactions. In other words, how can we quantify the solutions and the concentrations that we've been talking about? So I think this is going to fit very nicely into the skills that you've built up to this point, because we are simply going to be calculating quantities, right? Ratios, which we've been doing all along. For example, suppose we had a solution that had 8 grams of potassium iodide and 42 grams of solvent, right? What are we going to do with that? And remember, we were talking earlier as solubility as in the mass of the solute over the mass of the solvent, right? So you can see we can pretty easily just put that into that number as we have it. So, all right, but we're going to spend a good bit of time here in this section practicing it. So first of all, we're going to calculate the concentration of a solute in a solution. Then we're going to use concentration units to calculate the amounts of solute or solution, right? And then finally, given a volume and a concentration, we're going to calculate the amount of another reactant that is needed, a reactant or product in a particular reaction. This last one's gummy, and it'll make a lot more sense when we get a chance to look at it. So so let's go. So first of all, calculating concentration is our core chemistry skill here, and it's going to be an amount of solution typically over amount of solution. I don't know if I said that right. Can I say it again? The amount of solute over the amount of solution. Okay? So the amount of solute might be expressed in grams, milliliters, or moles. The amount of solution is oftentimes expressed in a mass or a volume. Okay, so and obviously we don't even have to know which one it is, right? We're given that in the question stem. So let's look at a particular example of this. Mass percent concentration is a mass per mass, right? So we have a mass of a solute over a mass of a solution, which is the sum of those two masses, right? The solution, remember, is made up of both the solute and the solvent. And so the mass percent is the mass of the one over the mass of the solution, okay? And this is just a reiteration of what we got up here. And look here, the grams of solute in 100 grams of solution is what we showed in the previous conversation as solubilities, right? The maximum mass of solute in 100 grams of solution is what is termed as the solubility. All right, so let's look at a particular example of this. When 42 grams, this is where we started our conversation today, 42 grams of water is added to 8 grams of potassium chloride, then the mass of the solute is equal to 8, right? Divided by the mass of the solution, which is equal to 8 plus 42, right? Right? Because remember, the solution is both the solute, which is here, and the solvent. It's the sum of those two. So it's going to be 8 over 50. All right, does that make sense? Okay, so let's do an example. What is the mass percent of sodium hydroxide in a solution prepared by dissolving 30 grams? Okay, so a mass percent is going to be mass of the solute over mass of the solution, right? Which is going to be, the mass of the solute is this, 30, over, and the solution is the sum of both of those, right? Because the solution is the solute plus the solvent, so it's going to be 150. So the mass percent is going to be 30 divided by 50, well, times 100, right? When we do percents, we convert it to that by multiplying by 100. So this is going to be 30 over 50, which is 1/5, which is 0.2 times 100, which is equal to 20%. Okay? Does that make sense? All right, so pause the video, do this learning check, and then come back and see my solution. Okay, let me suppose you paused it. So we're supposed to be calculating mass percent again. So I'm going to say mass of solute over mass of solution, right? Times 100%, because we're going to be changing the form to that, right? So What a solution is prepared by mixing 15 grams of sodium carbonate in this much water. Okay, so it looks like it's going to be 15. It's my solute. That's what gets dissolved. Okay, and my solution then is going to be the sum of both of these together. So it looks like it's 15 plus 235 is 150 times 100% is equal to, it looks like that's 10, or 1/10, right? So times 100% is going to be 10%. All right, hopefully that's helpful. Now let's talk about a different kind of concentration. This is a volume percent, which is volume per volume. Volume per volume. And again, all we're going to do is just obey the labels. That's it. It's going to be a part per whole, just like our last one, where the part is the solute and the whole is the solution, right? And a volume percent, another way to write, if we multiply by 100, another way to think of it is putting 100 mils in the bottom. That's essentially the same thing. So I'm typically going to go with this sort of solution. All right. So, well, we didn't do an example of that, did we? But we're going to still do, the third kind we have here is a mass per volume percent. A mass per volume percent, which will be given to you. The mass per volume percent is the mass of the solute over the volume of the solution. Mass per volume. Can you see it's sort of laid out for you right there? So I'm going to argue that this is going to be, you'll have some conversions to do, but basically if you read the labels and if you obey the labels very carefully, you'll be getting these right. Okay, let's go on to the next question. Here, pause the video and come back and do these and come back and see what I have to say about it. Okay, let me suppose you paused it. And so we're supposed to write 2 conversion factors for each solution. We did this a good bit earlier in the course. Write 2 conversion factors for this. So conversion factors for this are going to be, I can see if it's a 8.5% mass per mass solution, it's going to be 8.50 grams of sodium hydroxide over 100 grams of water. Right? There's a nice conversion factor. Or 100 grams of water, right, running out of space here, over 8.50 grams of sodium hydroxide. If you got this wrong, pause the video again and rewrite your answers for B and C. See what I did? 8.5% means 8.5 grams per 100 gram of water, right? Okay, so let's do B now. 5.75% volume per volume of ethanol. So that means 5.75 mils or liters, right, because it's a volume, of ethanol over 100 mils of water. Or no, solution. So this is going to be like vodka, right? 100 mils of vodka or ethanol solution. This is a mistake up here. I made a mistake. It's 100 grams of solution, not water. 100 grams of solution. That was a mistake. 100 grams of solution, because remember, we're doing part per whole. Part per whole, where the part is the solute and the whole is the solution, right? Okay. So in the solution, and with an ethanol solution, is going to be ethanol water, which I'm calling vodka, sort of as a joke there, right? Or 100 mils of, it's really ethanol solution. I'm just going to say solution here. I made a joke about it being vodka there, but that could be distracting if you're struggling to get a hold of this. Ethanol. And I also gave an abbreviation for ethanol, right? That was that. Hopefully that wasn't distracting. Okay, and the final C is a mass per volume, and that's going to be 4.8 grams, right, of HCl over 100 mils of solution, or the other way around, right? Okay, so hopefully that's helpful. All right, let's move on. Now, the most important kind of concentration is going to be molarity. This is the one that chemists use the most, molarity. And molarity It's got sort of an arbitrary definition, not something you could just figure out by looking at the M. Okay, and that's going to be moles of solute per liter of solution. Moles of solute per liter of solution. Now, 1 molar solution is defined as 1 mole of sodium chloride per 1 liter of solution. That's it, moles per liter. All right. So I'm going to show you an example of that, and then we'll do a learning check. All right. So let me come over here with red. What's the molarity of 0.5 liters? Okay, volume 0.500 liters of a sodium hydroxide solution if it contains a mass of 6.00 grams of sodium hydroxide. Well, I've got to convert this to moles because molarity is equal to moles per liter, and I have liters, but I don't have moles. So I've got to convert it to moles, and I'm going to do it by taking my molecular weight of sodium hydroxide and calculating that. So sodium hydroxide is it's got 1 sodium plus 1 oxygen plus 1 hydrogen is equal to about 23 plus oxygen 16 plus hydrogen is 1. It's about 40. Okay, so let's do it. Let's do the actual calculation here. Okay, and sodium is 22.99. 22.99, where was I? Let's go back over here. Let's do this in red. 22.99 plus oxygen is 15.999 plus hydrogen, which is 1.008. Okay, I'm going to get my calculator out and calculate the molecular weight then. Molecular weight is 22.99 plus 15.999 plus 1.008, which is equal to 39.997. Let me go back to black here. 39.997. And so the moles then is going to be 6 divided by that, right? Which is 0.15. 1500 moles. Okay, now I'm ready for this. Watch, look at that. I'm ready. I've got the moles, and the moles is 0.1500 moles over 0.500 liters, which is going to give me, watch this now, 0.15 divided by 0.5, enter, is going to give me 0.3002, and so on, right? Molar, because that's what molar means right there. That's molar. 0.300 molar sodium hydroxide. Wonderful. All right, and it's 3 sig figs here, so I'm gonna write this as 0.300 molar. All right, I hope that's helpful. All right, so come back and have a look at this knowledge check. Do this knowledge check, and probably should cut the video off here at this point, right? This is getting really long. Okay, have a look at this knowledge check. Pause the video and come back and compare your answer to mine. Okay, so I'm going to suppose you paused it. What's the molarity of 0.5? So I've got a volume is equal to 0.225 liters. And I've got a mass of 34.8 grams. But we're asked for molarity, right? So I need moles. And the way that I do that always is going through molecular weight. Of course, I have to do that. There's no other way. 34.8, and the molecular weight of potassium nitrate is potassium 39.098. 39.098 plus a nitrogen, which is 14.007, 14.007 plus 3 times oxygen, which is 16. 15.999. Enter. So the molecular weight is 101.102, 101.102, 101.102 grams per mole, right? And if I divide those, I'll get my grams, or my moles. Divided by 0.3442. 0.3442 moles. And so my molarity is going to be my moles per liter, which is 0.3442 over 0.225, which is equal to, divided by 0.225. Did I get that right? I did. 0.15, and to keep it at 3 sig figs, I'm going to go ahead and round it now. 153. No, got that wrong. It's 1.53 molar, and there is my answer. Love it. Okay, so I think what we'll do is we're going to save the rest of these points for another video. This is just getting too long. All right, see you in a minute.